1 unit, 2 unit, 10 unit, we can take it. It's based on the sensitivity of your parameter which you are studying. So let's say my mean ST of
Assam University
is 63 and 12 and
Delhi University
is 170 and 15. And my allowable difference is 7 unit. There is 7 unit difference in between 2, and even there will be 7 unit difference in between 2, I will say that both are equal. Now we have to calculate a sample size for this with 7 unit allowable difference. To facilitate this calculation, there is independent group, 2 independent group t-test involved. Now with this is a software screenshot. Let's see. So this is the actual computation with 7 unit difference. But if I will increase the difference or decrease the difference, what will be impact is demonstrated in further column. So let's focus here on the column. I have my alpha level, type 1 error 5%, two-sided test. My group 1 mean means
Assam University
163, group 2 mean
Delhi University
170. My allowable difference here is minus 7 unit. And then standard deviation in group 1 is 12, in group 2 is 15. 90% power, this will give me 81 sample size. Okay. Now if I want to reduce the allowable difference, see 163 India. Now if I want to reduce the allowable difference, then from 163, 5 unit plus or minus will be treated as a different. But less than 5 will be treated as equal. So with 5 unit, the rest of the thing is then C, the sample size increase. With 2 unit, sample size increase more. But if I make more difference as an allowable difference, bigger difference, sample size is less. So this is the relation between sample size and tolerance limit, allowable difference, and the variability. Now, from where this sample size calculation coming from? I would like to demonstrate you with the formula. Actually, anybody can generate that formula. It's not a big deal. Let's see this. So I have taken, for example, the Z distribution, Z statistics. Actually, it's Z statistics. So you may have gone through your statistics classes. That Z statistics is the sample mean minus population mean, sample mean minus population mean divided by sigma by root n. This is the Z statistics. Now, if any hypothesis testing I have to do with the Z statistics, in this statistics the n involved. So if I will get this n out from this equation, I can derive the sample size. This is the whole funda. So what I have to do? I have to find out which statistics I am going to use for my sample size calculation. And what is the formula for that statistics? Now I would like to take you in your classes earlier to plus 2, where we have read some couple of conjugate equation and solving those equations, taking the some value from left hand side to right hand side, denominator to numerator, all those concepts. So again here the Z statistics same. Now my target is taking this n as a standalone. So the principal rule is, if you take denominator to numerator, the sign will change. Means if you take denominator to other side, it will be a multiplicator. If you take minus to other side, it will become plus. If you take plus to other side, it will become minus. The whole funda is sign will change. So what I am doing here, I am taking this whole denominator to other side. See this, Z stand as it is, denominator come here as a multiplicator, rest the same. Now what I am doing, I am now taking this denominator this side. So keeping this z into sigma the same, and I have taken denominator to other side, it become the multiplicator. So root n multiplied by the same thing. Okay. Now we find this equation. What is ultimate objective is to take n as a standalone. So take this out in another side. So z and sigma is the same. I have take this out to another side. So this is a multiplicator. In other side it's become denominator. Root n standalone. Now root n equal to this by this. Now this is what? This is my allowable difference, delta. The sample mean minus population mean. The departure from population which we observe in the sample. Let's make it d. So I have write root n equal to z into sigma by d. Now take the square in both sides. So root n become n and this become as a square. Now here you got the sample size. N equal to z into sigma by d square. Very easy. For z statistics, there are couple of more statistics, which is t, chi-square and others. The derivation may go little bit complex. Luckily, we don't have to do. Softwares are there. They are already formula fed in that and they will compute for you. This is just, I try to explain that from where this whole computation coming from. A statistician is saying that this sample is sufficient, this is not sufficient. This is coming from this formula, and formula is coming from the statistics which you are going to use for your testing. There is a quite one-to-one relation here, straightforward. Now, this development of mathematical formula, if you can solve the above equation, which I demonstrated here, n equal to z sigma by d square, you got your sample size. So let's leave this task to the software and the statistician. We can do rest of the research. Now, this is concluding slide. What we learned till now. And basically, my whole talk was focused on the sample size estimation. So this sample size estimation, how much sample? Sorry, it's depend what you want to do. You want to do exploratory, you want to do estimation, you want to test hypothesis. It's depend. Now once you know what you want to do, then in your objective, do you know your parameter? On what scale you are going to measure your objective? And if you do, you have to do any hypothesis testing. What is your exact hypothesis? How to convert your objective in a mathematical function, like hypothesis or measurmental unit. If there is a confusion in this, we can connect with the statistician and jointly we can figure it out that what is my parameter, how I can measure it. Now I know my parameter, I know what hypothesis I have to test. So do we know a suitable statistics which can test my hypothesis or estimate my parameter? If I know, well and good. If I don't know, a statistician can help you out. Now, I am at the position where I know my objective, I know what parameter I am going to use, what hypothesis I am going to test, and I know with which statistics I am going to estimate and test my hypothesis. So then there is no problem. We can calculate the sample size now. So with the sample size calculation, software can help you out, or a statistician can plug in and try to compute the sample size for you. So when to contact a statistician? So as early idea come into your mind, you can connect so that the parameter can be set up, the hypothesis can be set up properly, the design framework can be go properly, and it can finally proceed a good good foundation stone for your whole research objective. Now, in this research, in this slide, I would like to emphasize that important aspect of being a statistician involved at the beginning of the study till the end. So in any research,